Okay, in this video, we want to take the derivative of y, where y is equal to x times the inverse sine of x, quantity squared, minus 2x, plus 2 times the square root of 1 minus x squared, multiplied by the inverse sine of x. And we want to solve this equation for dy dx. So starting with the first expression, we could have this times the derivative of this, and this would just be dx dx. So we would have the inverse sine of x, quantity squared, plus x times the derivative of this. And the derivative of this will be 2, take the power down, times the sine of the inverse sine of x, and that is now going to be raised to the 2 minus 1, or just to the 1 exponent. And then we have to take the derivative of what's inside of here. And the derivative of the inverse sine of x would be 1 over the square root of 1 minus x squared. And I have to take du dx. In this case, that would just be dx dx. You can write it down the first time here. But of course, that's just 1. And obviously, this is just the inverse sine of x. We wrote it like this in parentheses raised to the first power to remind ourselves that once we bring this down and we have the new exponent, we have to take the derivative of what's inside here. And the derivative of this is 1 over the square root of 1 minus x squared dx dx. And that's just 1, so we don't have to leave that there. Okay, and then here we have minus 2. Taking the derivative of this quantity with respect to x. And then here we'll have, now let's look at this. First, we can take the derivative of this, leaving this the same. Then afterwards, we leave this the same, and then we take the derivative of this. So let's take this derivative first. So we're going to have 2 plus 2 minus 2 came from here, plus 2 times the inverse sine of x. And now we have to take the derivative of this. We have 1 minus x squared to the 1/2 power. So that's going to be this, and let's just multiply these in parentheses just to make sure that we don't get things mixed up here. I'm going to have 1/2 times 1 minus x squared, and the new exponent is going to be 1/2 minus 1, or that's minus 1/2. Then we have, remember, take the derivative of what's inside of here, and that's going to be minus 2x. 2x, and if we wanted to do a formula, we would say dx dx, but of course that's just 1, so typically we don't bother to write it down. Okay, that was this times the derivative of this. Now we have this part times this derivative. So we have plus 2 times the square root of 1 minus x squared. And the derivative of this is going to be 1 over the square root of 1 minus x squared times this derivative, which again, that's just going to be times dx over dx. We're taking derivatives with respect to x, so that's just going to be 1. And this is just going to be 1 divided by itself. So here we have plus 2, and from this derivative we have minus 2, so these are going to cancel. So let's do away with this and make some room. And we will now have, and this one is gone too, so this will equal, make some more room here, inverse sine of x squared plus 2x times inverse sine of x to the first power, so that's just this, divided by square root of 1 minus x squared. And then from here, these are going to cancel out, but we're going to have minus 2 times this divided by, because this is a negative exponent, square root of 1 minus x squared. And from here we have an x, so we took this derivative inside here. So you can write that right there. And once we clean this up, it looks like these two terms here are going to cancel. So right here is our answer. So that's it. Problem is finished. Again, there's nothing really tricky to it. It's just using what you've been learning all along. Here we have two functions multiplied together. So we're going to have derivatives, this times this derivative plus this times this derivative. And we encountered that same situation over here. So we decided to kind of work through it step by step. And we did that. It turns out that we had a lot of cancellations, and this was the only term that was left over in the end. But okay, that finishes it off with this problem. I don't think we've had a video yet where we've dealt with an inverse tangent problem, so we'll try and have one of those ready maybe in the next video.